Okay, probability tree diagrams. Let's just look at this a couple of examples together and then have a go at some yourself. Ding is going to play one game of snooker against each of his two friends, Marco and Judd. The probability tree diagram gives information about the probabilities that Ding will win or lose. So first thing to note, each branch adds to one. It adds to one, adds to one, adds to one. Got to make sure each of your branches add up to one. Work out the probability that Ding wins both games. So here, this is from a win and a win. So that's your outcome really, win, win. And it's win and a win. So we multiply the probabilities together. So 0.6 times 0.9, 0.54. I'm just going to write that here. And we did 0.6 times 0.9. Work out the probability that Ding wins at least one game. Well, this is a win-win, so we need that option. Here, he wins the first game. So if I travel along this branch, it's win and lose. Well, yes, he's won at least one game. So that's 0.6 times 0.1, which is 0.06. Here, Ding loses and then wins. So yes, he's won at least one. So 0.4 times 0.25 is 0.1. I'm just going to work out this bottom one as well. Although it's not an option we need because it's lose and lose, but I just want to point something out. This is 0.3. Another check you could do here is all of these add to 1. So it's helpful to see if you filled in the tree diagram correctly. Yes, they add to 1. Now, let's just see what we need here. So, work out the probability that Ding wins at least one game. So as discussed earlier, we need the top option, this option, and this option. So it's this option or this option or this option. So we add the probabilities together. 0.7. Work out the probability that Ding wins exactly one game. Well, exactly one game. What are we looking at here? Exactly one game. Yeah, that's exactly one game. Exactly one game. Yeah, that's exactly one game. None of the options are. So we're going to add together 0.06, add 0.1, which is 0.16. Okay, you might be given your probabilities as fractions, but it's the same idea. Soccer team plays 2 matches. The tree diagram shows the probability of the team winning or losing the matches. Find the probability that the soccer team wins at least one of the 2 matches. So the top one is win-win, win-lose, lose-win, lose-lose. At least one of the 2 matches. So they win at least one of the 2 matches here, 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 not there. So 1/3 times 3/4. You could just simply type this on your calculator. It will simplify it for you. 1/4. Don't forget we're multiplying them together when we travel along the branches because it's win and a win. If you'd have just multiplied the top and multiplied the bottom, it's 3/12, which is the same as 1/4. Here we'd have 1/12, and here we'd have 6/12, but if you've done it on the calculator, it will give you a half. Okay, so we've got all those options. What do we do with them now? Well, it's or this or this or this, so we add them together. So 1/4 plus a 12 plus a half, and IGCSE is all calculator. So let's just add them together. 5/6. Okay, have a go at a couple of questions yourself. Put me on pause, unpause when you're done, see how you got on. Okay, so we've got Wendy goes to a fun fair. She has one go at Hoopla, one go at the Coconut Shy. Probability she wins is 0.4 for the Hoopla. Coconut Shy is 0.3. Complete the tree diagram. Will each branch add up to 1? If the probability she wins is 0.4, you minus that off of 1 to get 0.6 here to get the probability she does not win. Same here, got to be 0.7, and this would be 0.3 and 0.7. Find the probability she wins exactly one game. Well, she's won 2 games at the top, won 1 game here, and won 1 game here. So we need 0.4 times 0.7, 0.6 times 0.3, and then add them together. Gives us a final answer of 0.46. Okay, for these, there is no tree diagram. We're going to have to draw our own. Tina has 2 bags of counters, bag A and bag B. Bag A, there are 5 red and 3 blue. Bag B, we've got 4 red, 5 blue. Tina takes at random a counter from each bag. Right, so the first event is taken from bag A, and the second event is from bag B. So what are the options for bag A? Red or blue? What are the options for bag B? Red or blue? Red or blue? So from bag A, 5 out of 8. For blue, 3 out of 8. And here for red, for bag B, we've got 4 over 9, 5 over 9. Work out probability she takes 2 blue counters. Blue and a blue is the bottom part of our tree. So 3/8 times 5/9. 5/24. Hannah is going to play 1 game of chess and 1 game of backgammon. So my first event will be chess. My second event will be backgammon. So I'm just going to put win, lose, win, lose, win, lose. Okay, so for her chess, probability she wins is 0.6. Lose would be 0.4 because they need to add up to 1. Backgammon, probability of a win is 0.3. 7 even, lose is 0.3. Win 0.7, lose 0.3. Work out the probability Hannah will win both games. So it's the top branches, win and a win, 0.42.